Good evening, students. Today we are going to continue with the chapter surface area and volume. Today we will discuss about how to calculate the surface area of cylinder, cone, sphere and hemisphere. We have already discussed in our previous lecture about the cuboid and cube. There we had discussed about how to calculate the surface area. Surface area can be of two types, either curved surface area, also called as the lateral surface area. Another one is the total surface area, where the surface area of bottom and top have to be added in the lateral surface area if the bottom surface area and top surface area exist. Like in cone, only bottom surface area, no top surface area. In cylinder, both bottom and top surface area. In a sphere, there is no bottom and top surface area. So for a sphere, the total surface area is same as lateral surface area. These things we had discussed earlier. Okay. So now today, let us continue with the cylinder. So a student, for this cylinder, how this cylinder is obtained. So students, in previous classes we have learned about the disc and ring. We have learned that ring is like a circle and the area enclosed, if the area is also packed, then it forms a disc. Like here in this figure on left hand side, a disc is drawn. So this is a circular disc. It is a circular disc. Disc means the area is filled, means area is enclosed. Like if you are taking the plate or any circular plate where you are eating or taking the food, the base of that is also a circular disc. But if you are just taking a ring or a bangle, that is formed just a circle. So that difference we have to understand. Now when this one disc is placed over another, that leads to formation of cylinder. So cylinder simply means from inside it is solid. If the inner one is not solid, how it can be formed? By placing one ring over the another or one bangle over the another. At that time, that kind of cylinder is called hollow cylinder. If nothing is mentioned, you shall always consider it as a solid cylinder. If it is hollow, then surely in question it will be given that a hollow cylinder is there. Okay. So for this cylinder, the circular discs are placed one and over another to form this cylinder. Now in this case, we can have two kind of area. One is the area around the curve, means exclude the top surface and bottom surface which is flat. So that curved surface area is also called as lateral surface area. And this lateral surface area or curved surface area can be calculated just by knowing the circumference of this ring. If you want to just know the boundary length of this disc, only this much boundary length, forget for the area enclosed, only this boundary length we are considering. So the boundary is here circular, therefore the boundary length can be calculated by the formula of circumference of a circle. And this boundary length, are you getting? This boundary length is your circumference. And this circumference is calculated by 2 pi r. It is one thing. But if we want to know the area enclosed by this boundary, the area is what? A circular disc, area of circular disc. Then this area area is calculated by area enclosed by this circle, that will be given by pi r square. Okay, student. So these are the things for this circular disc. Now we have to understand two things. One is its area, the curved surface area. Another one is the total surface area. Then we will understand its volume also. So students, for this circular disc, we have circular boundary, length. This circular boundary length, what is marked here in this blue color, this circular boundary length is called as circumference, and this is calculated by 2 pi r. It is just like a ring or like a circle. But area bounded or sometimes also called as area enclosed mean the same thing. By this circular boundary or by the disc we may write, or this circle we may write, is the ring. So here we are talking for the area. Area is the area of circle, and this area of circle is given by the formula pi r square. Okay, student. Now we have to understand two things. One is called the surface area. So for this surface area of cylinder. Students, here we are getting that this surface area means the curved one. One is this curve, another top and bottom are the flat. So how this curved surface area can be obtained? Just by calculating the length of one circular boundary, and that have to be multiplied with height of the cylinder. So if we consider height of this cylinder, means these rings are stacked, means placed over one another up to height h. So therefore, for calculating the curved surface area, first we need to just calculate the boundary length of this ring, and that have to be multiplied with height h, so that the entire curved surface area we can get. So for surface area, two kind of surface area. The very first one is the curved, also called as lateral surface area, written as CSA or LSA, mean the same thing. So this is calculated by, how we are getting, students? So just this boundary is there, or a circular boundary is there. This circular boundary have to be placed one over another. See this boundary, above this there is another 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 boundary, another boundary. This way we are getting that a cylinder is formed. Are we getting? Means this boundary is placed, means if we consider one boundary length of this, it is our 2 pi r. So this boundary length is our 2 pi r, but this boundary length one over another, over that another, up to this much. How many such boundary length are there? There is h boundary length. Okay, students. So up to this h boundary length, for getting the total, for getting this entire lateral or curved surface area, I need this boundary length, and this length have to be multiplied h times so that its height will raise. So write this CSA or LSA is obtained by multiplying this 2 pi r with their height.
Right.
Because one ring have the outer surface area or the thin ring boundary length as 2 pi r. So that is placed one over another up to h time. So entire surface area because of that thin ring is obtained by just multiplying it h time. So therefore, this CSA is obtained by the formula 2 pi r place it h. Okay,
H.
this is the formula. Getting a student? Now let us come to the, whether you write the CSA or LSA mean the same thing. Now the second kind. So student, what we have calculated is only this much, this boundary length. Here we have to understand only this curved, this boundary length we have calculated. Still what is left? Still left one is their top and their bottom. Still we have not counted for this, the top, and another one is also their bottom. Bottom is since hidden, so perhaps we may not draw like that, like we have done for the top surface. Here you can see in this figure, see, it is the top surface area of top, and another is the surface area of bottom. Get it? So whatever we have calculated, this CSA is our 2 pi r into height h. It is this one. Now for calculating the total surface area, the bottom one and top one area have to be added. So let us go for that. So the second one is our total surface area, total surface area of whom? It is for this cylinder we are calculating, students. So how that TSA is obtained, students? TSA is obtained by adding the bottom surface area and top surface area and curved surface area. So if you have calculated the curved surface area, in that you have to add the surface area of top and the surface area of bottom, these two things. Now observe carefully. What is the surface area of top, student? Our top surface area, this one will be same as this one area. This is our pi r square. So this top surface area will also be pi r square. Bottom one is also a circular disc, so its surface area will also be pi r square. Are you getting? Here r is our radius of this cylinder. Means from here to here, it is our radius and the height. Like here we have drawn. For this, r is the radius of the same disc, or same is the r, radius of the cylinder. Are we okay? And h is the height. So therefore, this total surface area is obtained by CSA we have calculated as 2 pi r into h plus the surface area of top. Top one is the flat disc. It is the disc area, means the top disc you may write. It is also a disc area, but this one is our bottom disc. It is this one. So surface area of top, pi r square. R is the radius of that disc or radius of same cylinder, and bottom is also pi r square. So adding these two, what we can get? A student, 2 pi r h
2 pi
plus
r h
2
plus
pi
2 pi
r
r square.
square. Even here, we can take this 2 pi r as common. We will be left with h plus r. Therefore, this TSA is calculated by the formula 2 pi r. Take it outside, and inside the bracket, you have to
H
add
plus r.
r plus h, or h plus r mean the same thing. So it's so simple, students. You have to just observe it carefully what is being asked. So by applying these two formula, the surface area can be calculated, and if cost is given, that have to be multiplied with the cost. That technique we had already learned in our previous lecture. So this was about the surface area of a cylinder. Now if we come to the volume, the third one is, or let us come for the, let me write here itself, volume of cylinder. It's very easy to understand how this volume or this space is occupied by placing the disk of area pi r square up to height h. It means for considering the space occupied, I need to multiply this pi r square, which is the surface area of a disk, with the height h, rather than 2 pi r. So multiplying 2 pi r with h is giving the curved surface area, but multiplying pi r square with the h can give us the volume. It's so simple. So we can write here volume of cylinder is equals to the area of one of the disk, and that area have to be multiplied up to h time, this time forgetting the volume. Why? Because one disk is placed over another up to h time, so entire space get packed. This time we are calculating the volume, means how much space it have occupied. So it is obtained by calculate the base area or the circular area multiplied by its height. Earlier, student, we had taken this ring area only for this LSA, lateral surface area, because it was the boundary under consideration. But this time for volume, it need not be boundary, entire to consider. For that we need to take the base area, means it is our pi r square into the height h. So volume of cylinder is obtained by pi r square into h. Students, here we have to keep in mind the difference between CSA and volume. Observe what is the difference. The difference is that for the curved surface area or lateral surface area, we need to multiply 2 pi r with h. But for the volume, we need to multiply its area pi r square with h. Okay, so this we have to keep in mind. And the third, for the total surface area, this 2 pi r bracket r plus h. So these are the three important formula that we need to keep in mind. We will solve some of the question based on that, based on this. So let me take one of the question from your textbook. So for the cylinder, the same figure we had explained. Height h, the circular boundary, how is that? That is the height h with the same length. And for total surface area, the same kind of addition. Let me take the question number 2 and 3. I'm going to solve these two questions, students. Sorry. So this is the question taken from your textbook, exercise number 13.2. Exercise 13.2 from our textbook. Let me solve both the question one by one. A student, the very first we have to draw the figure for this. Then what is required? For that we will search the formula, applicable formula, then we will substitute to get it. It is required to make a closed cylindrical tank. Are you getting? Of height 1 meter and base diameter 140 centimeter from a metal sheet. How many square meter of this sheet are required? Students, here it is given that a cylindrical tank have to be so this is the cylindrical tank. Let me take a cylindrical tank. So base and top, they are the disc. It have some height h. So height is given as 1 meter, and it also have some radius r. The radius r is given as 140 by 2 because diameter is given in the question. So it is obtained by 140 by 2 is equals to 70 centimeter. Or you may write down the given quantity, or over the figure you can write whatever is given by labeling the figure. So this is to be prepared or to be made from a sheet. A student, how we can make this a closed cylinder? So first, if you open the curved surface area, then you can get a rectangular sheet of same height. If you cut it from one of the height, means along the height, then you will get such a rectangular sheet that is to be folded to get the curved surface, like a plane paper can be folded, not folded, can be rolled to get the cylinder. In addition to this, we have to make another 2 circle. Getting a student? This circle, yes, tell me.
Sir, it's 43 centimeter.
43. Which one?
That 146 divided by.
It is 140. Student, it is not 43. Perhaps observe it carefully. You can get it is not. It is 4040 is there. It is given here in question that it is 140 centimeters. So we should be careful that it is in centimeter the radius, but height is in meter. So if both of them should be brought in same unit, either in centimeter or in meter, that we will do. That is one thing. But what I was doing, or we may write this 70 centimeter as 0.7 meter. You may write like this one, the radius. Now this box have to be made from a bigger sheet. whatever the sheet dimension may be a very big sheet. From that sheet, you need to cut one such rectangle for making their curved surface, and another, let me take this rectangle taken from here to here to get this. So whatever this length, what will be the length, that we have to understand. So while you are opening it, the length, it is rolled along like this. So the length of this should be same as the circular length. What is the circular length? It is obtained by 2 pi r. So this length should be 2 pi r. But what will be the height? The height is same as this height. So height should be
1 meter.
same as 1 meter. But this can give us the curved surface area. But we need to close it from the top and bottom. For that, we need 2 more circle. Getting? It is for the top, it is for the bottom. And question is asked, how much sheet area is used? So how much area will be used, students? Here, whatever the area of this rectangle that is cut from this sheet, one part will be this one.
Plus 2 times.
Yes, the other part will be for their top, another part will be for their bottom. Are you getting? So questions are very simple. So therefore we shall write these two, or we shall also draw 2 more circle. So this is for the, we may write as the bottom surface area. This is for the top surface area. So these two. But how to calculate this surface area? The radius is given as same as r, and r, it is our 0.7 meter. 0.7
meter.
So this area, all this area we need to first calculate, then we need to add it. Okay. So therefore we are just drawing it here, then we will add it together. So one is this rectangular area, another will be this circular area, and this circular area. So questions are very easy. You have to just understand. You must analyze rather than just mugging up. You just understand. Means what we have done, we have taken this rectangular sheet. From this rectangular sheet, means this is the rectangular sheet. Rectangular, or you may just write as the metallic sheet. It is from which this is to be cut. Metallic sheet. From this, you need to cut these 3 pieces. It is your piece 1, it is your piece 2, it is your piece 3. So these 3 pieces we have redrawn here. From this, the 3 parts are taken out. Getting? So these 3 parts have to be added. So the question is, how much a square meter? A student, it is asking in meter, a square meter. So that's why we have converted this radius into meter, which was given in centimeter. Since diameter was given as 140 centimeter, from this we have calculated the radius as 70 centimeter, and that we have converted into meter, because answer required is in meter. If it was asked in centimeter, then better to convert the height 1 meter into 100 centimeter. Okay, so observe the question carefully and find it. Are required for this same. Okay, so now we can write area of sheet required, area of sheet is equals to how much? It is nothing but it is the total surface area of cylinder. This we may write as the curved surface area of cylinder plus surface area of bottom and top, or we may write the rectangular surface area with length 2 pi r and height h, that we can get, plus the circular area for bottom plus circular area for top. So these three pieces we have to write. A student, just by rolling this or multiplying this 2 pi r with height h, we are getting the same as CSA. Getting? So even I have opened this into rectangle. Understand that this cylinder is obtained by rolling a rectangle which have the boundary length or which have one edge length as 2 pi r and another side length at height h. Okay, so this way we can calculate this as TSA. How the TSA is calculated? 2 pi r have to be multiplied with this h.
R plus h.
Good. So this 2 pi r we have taken, this h we have taken for this rectangular sheet, plus the bottom, it is obtained by pi r square. This area is also obtained by pi r square. So pi r square plus pi r square, it becomes 2 pi r square. So even 2 pi r can be taken outside, it becomes h plus r. It's okay. Now let us substitute. A student, I had already advised you, first you derive the formula and finally you substitute the value. So here it is obtained by 2 into 22 by 7 into r is given here 0.7. Okay, students. Then h is 1 meter. Everything is in meter. We shall be careful. 0.7. Entire area is meter into meter, meter square. Okay, or a square meter. So these 7 can be cancelled as 0.1. 2 2s are 4. Okay, so 44, it becomes 4.4 into 1.7. Okay, students. So you have to multiply this 4.4 with 1.7 to get the required answer. So let us go for multiplying 4.4 with 1.7. Very good. So on multiplication you will get as 7.48 meter square. Okay, student. So questions are very simple. You have to just understand what to do. Okay. Otherwise these questions are very simple. It is one thing. So here we have calculated the surface area. The other thing here may ask like this, also add it here, also calculate the capacity of cylinder. Capacity of cylinder means the volume of cylinder. The capacity of cylinder, or maybe ask volume of cylinder, mean the same thing. So students, in capacity or volume, what to do? Nothing but just apply the formula. That's all. There is no difference. So the formula for the volume, this was the first part. The second part, capacity of cylinder same as the volume of cylinder,
pi r square h.
Very good. So it is obtained by base area pi r square and then h. Be careful, student. It is our 22 by 7 and r is our 0.7 square into height is 1. Student, 0.7 square means meter we have taken. So it becomes meter square and 1 meter. So total volume is given in meter cube. So just simplify it. it becomes 22 into, you may 49, 7 7 are 49, so 0.49, or better to cancel this 7 with one of the 7. So 0.1 into 0.7, so 0.07. Is it okay? Yeah, student, are you getting this?
Yes, sir.
So we have just cancelled this 7 with the square become as 0.1. So this 0.1 have to be multiplied. So it was like this one. Let me explain. 7 into 0.7 into 0.7 into 1 can be left. So this get cancelled with 0.1. So it becomes 22 into 0.7 into 0.1, it becomes 0.07. Okay, student? So multiply 0.07 with your 22. You will get how much? You will get 1.54, but the unit is this time meter cube. So unit is very important. It may be asked to convert it into liter. So 1 decimeter cube is 1 liter. So this you have to multiply with 10 to the power 6. That much liter you can get. So that conversion we will see later. One of the question is there in our volume that we will do. So it was about the question number 2. See, a student, in question number 3, the metallic pipe 77 meter long. See, this question number 3 is exactly same as question number 2, where the height is given as 77 centimeter, inner diameter of the cross section 4 centimeter. This one is the 4 centimeter. The outer diameter means the bigger one, 4.4 centimeter. Then we have to calculate this. So let me explain this. In this case, a student, it is given that it is a pipe, means the inner one is hollow. So it is like hollow cylinder. So we need to calculate inner curve surface area, outer curve surface area, and total curve surface area. So let us understand this question number 3. This is another important question which is asked most frequently. So for this question number 3, we should be careful regarding whatever the data given and what are the information. The given figure is a smaller, so let me draw a bigger figure where I can represent the inner radius, outer radius. So question number 3, I am going to solve it. For that, we shall draw this pipe. A student, you are observing that all the pipe have certain thickness. Okay, though it may be very lesser, say in mm, or if you are taking the bigger pipe, you will get the thickness of metallic sheet. You can observe it very carefully. So it is given here. This is a pipe. It has some inner diameter and the other one means the outer one is also means this have the thickness. It is filled with material. So we shall draw the figure carefully. I'm just magnifying that given figure so that we can understand it. Students, here this part, I mean this is filled with material, it is not empty. It is filled with material. The material is laying between these two. The inner one is hollow, so that water can flow through this pipe from the inner surface. Are you getting? This is the figure. So here we can understand that it have one inner surface, another outer surface. So this will be the inner surface, inner surface. It is also your surface of the inner cylinder. Means you can understand this is the inside, means two cylinders are placed one over the another. And the other one, this one is our outer surface. But for calculating this, we need to know their radius. Since these two cylinders are concentric, means they have the same center. So for the inner cylinder, the radius is same, and it is given that for inner cylinder, the radius, we may write the given thing here, inner cylinder or the inner surface, the radius, let me denote it by Ri, is given as 4 centimeter. But the other one is of the bigger length, which can reach up to the outer one. So let me denote it by R out. And the outer cylinder, its radius, how much? It is given here 4.4.
Sir, it is diameter, sir.
Yeah, very good, student. So diameter is given. So 4.4 have to be divided by 2, this much centimeter. 4 divided by 2 centimeter. So Ri become 2 centimeter and R out become 2.2 centimeter. Okay, students. So this way we have to understand this question. After knowing this inner radii and outer radii, the inner surface is like one of the cylinder, and how it can be obtained? So inner surface area can be obtained by taking 2 pi r of which one radius? The inner radius, Ri.
Linear.
And the height, keep in mind the height h remains the same. So height h is same for both. It is given as 77 centimeter. So we may write here height of both cylinder, h is equals to 77 centimeter. All the unit are same. You are observing height in centimeter, radius, both the radius are in centimeter. So we can calculate the answer in centimeter square. So for calculating the inner surface area, we shall use the inner radii and height h. Means we shall use 2 pi Ri and the height h. For outer surface area, what we need to use? The outer cylinder. So 2 pi r out and their height h. So this way the curved surface area, means inner curved surface area, is calculated. Outer curved surface area. So these two are the curved surface. Okay, now these two are the curve. But another one thing is asked is for the total. So student, what we have calculated by these two formula is the curve one. But here we are observing another interesting thing, that if you are observing at the end, you can get this kind of ring which is formed. Are you getting this? Yes, student?
Yes, sir.
So one ring is here, another ring is here. These two rings are not counted while we are considering the inner and outer curved surface area. So these two rings also have to be understood, and that we need to count. Students, if we are considering the ring, one is this. Let me draw the bigger view. Another one is this. The RI is this one, and R out is the bigger one is this one. We should be careful while we are denoting. What is the area required? The required area is our this much, student. This is our required area. How I can get this required area? You can understand this area can be calculated. It is of the equal width everywhere, though in flat form we have drawn it a bit more on the two sides. But it is of the equal width. Okay, student? So how to get? A student, first we can get by calculating the entire surface area of this bigger disk, means the entire yellow area. How this can be calculated? By 2 pi r out. No, that will give us the boundary length. We are interested in area. Okay, so here we can understand the required area is only in between these two. So this required area can be calculated only by observing these things. Sorry. Students, here we have to be careful. The required area is only this much yellow. Sorry, it have again gone something wrong. It is only this much. That we need is only this much annulus space. I mean the space between the two cylinders. That can be obtained by taking the difference of the circular area of bigger circle minus the circular area of a smaller circle. So this space, this area we need. So area of circular, this is in between, there is a cutting that is called sometimes called as the annulus, or we may write this only as the circular band only, is equals to how much? Total bigger area means the entire yellow. If I am marking this entire by this entire yellow one minus the smaller one that can be subtracted. This one, if we are going to subtract, means going to remove this part from this bigger one, we will left with only this much. Are we getting? So this can be obtained by taking the area of bigger disk. So area of bigger circle minus area of a smaller circle. A smaller circle. Here area of bigger circle is obtained by pi r out square.
Pi r o.
Yes. And inner one pi r I square. So these I have calculated for just only one. Say for the top. Similarly, for the bottom is also there. So we need to multiply it twice for adding the top and bottom. Okay, area of circular band means 1 only, 1
into 2.
Yes, here I have calculated this for 1. So for the top band and bottom band, we will just multiply this. So this way I had explained you what are the different type of area in this and what we need to do. Now let us come back to the question and let us find it quickly. Very first one is our inner curve surface area. So write it. Inner curve surface area. This is obtained by how? 2 pi ri h. So 2 pi ri into h. So 2 into 22 by 7 ri. Here it is, we have calculated 2 centimeter because the internal diameter was given as the 4 centimeter. So it is our 2 square. The height h is given as 77. So we can calculate it. It become 11. So students, we need to calculate it. How much it become? 2 into 22 become 44 into 2 to the 4 means 2 square into 11 another 44. So just calculate it. 44 into 44, you will get the answer as 1936.
1003.
Very good, centimeter square. It is this one. First one was this one. Now come for the outer curve surface area. It is obtained by 2 pi r out into h. 2 into 22 by 7. This time
Into
our outer
2.2.
radius is very good, 2.2 square into 77. So the values you have to substitute carefully. So it becomes 44 into how much? 11 or into or 2.2, we may first make it a square. You will get this as 4.84. 4.84. Multiply this by the 11. You will get 53 point. So 44 into 53.24. Multiply this. These two, while multiplying, you will get the result like this. 2342.56 centimeter square. Unit is important, so do not forget to write the unit. Centimeter square. Okay, student. Now the third one is our total surface area. Total surface area is equals to how much, student? Here we have to understand the inner, the outer, and the two LO. All these three have to be added. Okay. Earlier in solid cylinder, inner surface was not there. So we need, for calculating the total surface area, we need to calculate the inner curved surface plus outer curved surface plus outer curve surface plus what is this? The top circular band plus bottom circular band. Okay, the top circular band plus bottom circular band. Let me first substitute in form of formula. For inner one, it is our 2 pi RIH. For the outer one, it is our 2 pi R out H. For the top band and bottom band, both are of the same kind, and it is obtained by pi R square.
PR square.
So first, for the outer one, pi R out square minus pi RI square. You may write this as pi R out square minus RI square. Taking the pi outside as the common, we can calculate this band area by pi R out square minus RI square. It is important. So pi R out
Into 2.
square minus RI square. Very good. But this is for the top. Bottom is also the same. So can I write the two together? So it become like this. So if you wish, you may substitute the values, or if you want, you may calculate it separately, 2 pi R out and RI square. Let me take this 2 pi outside, or let us directly substitute the value. Okay, student? So student, for this we have calculated, see, for this first one, we had calculated how much? 1936. The second one, the same calculation, is our 2342.56, and twice into pi is our 22 by 7. R out means 2.2 their square minus RI 2 square, but these have to be kept within one bracket. So this calculation we have to do. So you have to keep patience in this calculation. So let us do it. So adding the first two, let me keep by adding the first two, 1936. Adding the first two, we can get 4278.56. Now we have to simplify the second one. 2 into 22, we can write here as the 44 first. Have to be divided by 7. Now how to get this? This can be obtained, a student. I had explained you earlier, if I have the a square minus b square, then I can write this as a plus b into a
Plus B
minus.
bracket A minus B.
This way, this helps in simplification. Even without calculator, we can calculate it. So just adding this, 2.2 a square minus 2 a square can be written as 2.2 plus 2 in one bracket and 2.2 minus 2 in other bracket. Can we write like this? Surely. Adding this first bracket, it becomes 4.2, and subtracting in second bracket and writing it in multiplication, it becomes 0.2 only. Okay. So rather than going for squaring the 2.2, then taking difference, we can write this as the product of 4.2 into 0.2. This helps us in cancelling the denominator. So it becomes 0.6. So it becomes like 4278.56 plus 44 into multiply it. 6 to the 12. So 0.12. So go for just simplifying this. 4278.56 plus, let us first multiply 44 with 0.12. We can get this as 5.28. Just go for adding 4 to 7
2.
8 point, yes, so 0.56 we are able to get. 4 to just 5 is being added, 83 it becomes.
3.84.
Very good. So this much centimeter square. Okay, student. So it is so simple kind of thing. So this way the total surface area we had calculated, and it's very simple. So we should be careful how to calculate the total surface area that I had explained. A student, in the same question in next exercise you will be asked for calculating their volume. So what to do? Volume is even more easier than even this one also. I'm going to explain that concept.
By R square H.
Good. But in this case, how the volume can be obtained? The volume of outer cylinder minus volume of inner cylinder. It's that much easier. So only that we are going to do. So first we will calculate the volume, then their difference we need to just take it. So apply the formula for calculation of the volume. Okay. So let me add one more thing. Also, so write in this fourth, also calculate the volume of material of pipe. What is the volume of this? So how we can obtain? If it is totally solid, then it will be simply the outer cylinder, that much volume. But inner one is the another inner cylinder is there, that much have to be made empty from this outer cylinder. So the total volume of material is equals to volume of outer cylinder minus volume of inner cylinder. So that I'm going to write it directly. So volume of material is equals to volume of outer cylinder minus volume of inner cylinder. It's that much easier only. So let us calculate. For outer cylinder, the height of the
Pi
outer and
R
inner cylinder remains the same. So pi
Pi
r
R
out
square.
square and the height h have to be taken. For the inner cylinder, the radius become Ri, but the height remains the same. So we need to take the same height. Take the pi and h outside, it become R out square minus Ri
RI
square.
square.
Okay, student? Or you may understand this in another way, students. We had calculated this annulus space, this one, and this one space have to be raised how much? Height, the height h. So this even we had calculated earlier as the pi r out square minus pi ri square. So if this r out square means this annulus area or this circular band is multiplied by height h, we can get the volume, and we are getting the same thing. Okay, so the method 2, even I have explained the alternate method. So volume is obtained by this pi r out square minus ri square This can be multiplied by height h. We will get the same. Okay. So whether you take the difference of entire volume of outer and inner, or you calculate the band area and multiply it by h, you will get the same formula. Are we getting? So whether you calculate by any of the method by substituting the values, so 22 by 7 into height is 77 centimeter, and this we
into
had even
2.2.
calculated. Yes, so 2.2 square minus, let me
2
once
square.
again substitute so that our other student can understand it better. So
A
it
square
becomes
minus B square.
11. Yes, so we may calculate like this. So 22 into 11, shall I multiply it first? Into 11. So yes, it becomes 242 into these two can be written as addition than subtraction. So 2.2 plus 2, 4.2 into the subtraction is 0.2.
0.2.
Yes, so very good. So it is like 4.2. First we can get this one. So if I am multiplying these two first, you will get as 1016.4 into 0.2. I am doing this is smaller calculations because even in class 9th you people are committing such simpler calculation. If I just write the final value, you will get, or you are getting some difficulty. So multiplying this 0.2, you will get, it become 203.
203.28.
Point 2 point is there, so the point have to be shifted 2 unit leftward. So this much, what is the unit?
Meter cube.
Student? It is volume. Very good.
Meter
It
cube.
is centimeter. So student, it should be centimeter. Are we getting? So it's so simple, student. You can calculate the volume as well as the surface area. So both the concept we have understood. So this way we have finished this cylinder. You please try the other questions. They are very easy. If somewhere some cost is given, you have to just multiply the area with that cost. That's all. Okay, students? So next, another two kind of figure or shape like hemisphere and cone we will finish tomorrow. So tomorrow we are able to finish this chapter. So student, write down the homework. So you please finish your textbook exercise, which one? 13.3 or 2 is there?
13.3.
It is 2 or 3? I think it should be 2. Yes, 13.2, please finish you all these 11 question. Okay, and tomorrow morning we will conduct the class. So I hope by that time you should be able to finish these questions, so that if you have any doubt